Those perfect tomatoes on the ketchup bottle label are nothing like the green, flavor-lacking varieties used in mass production, harvested early and artificially ripened with ethylene gas. In this video, we're exposing the complete journey from farm field to bottle cap. As automotive enthusiasts who appreciate precision engineering, you'll discover production lines that operate with the reliability of a finely tuned engine. These mechanical marvels process 300,000 pounds of tomatoes hourly, roughly the weight of 100 cars, transforming everyday produce into the exact same product every single time through surprisingly complex methods we'll reveal throughout. Ever notice how tomatoes on your vine look nothing like what ends up in your ketchup? There's a reason for that. Those juicy, flavorful tomatoes growing in your garden would actually make terrible ketchup. The tomato industry has a secret most consumers never see, a parallel universe of tomatoes specifically engineered for processing, not eating. Commercial ketchup starts with specialized processing tomatoes that bear little resemblance to those plump red fruits on product labels. These industrial tomatoes function like high-performance engines, designed with precise specifications for a singular purpose: maximum processing efficiency. They contain up to 30% more solids, significantly less water, and feature thicker skins with a concentrated flavor profile. While perfect for reduction into paste, they'd be absolutely disappointing on your sandwich. Too firm, less juicy, and borderline unpleasant when raw. Surprisingly, these tomatoes are harvested while still partially green and hard. This makes perfect sense in the industrial context. Firmer fruits survive mechanical processing better and continue ripening during transport, maximizing both durability and flavor development by the time they reach processing facilities. Let's shift our focus to the harvesting technology, which transforms fields into factories. Modern tomato harvesters are engineering marvels that process up to 70 tons hourly. These aren't simple picking machines. They're rolling quality control centers equipped with electronic color sensors that analyze each tomato in microseconds. The technology can detect subtle ripeness differences and identify defects invisible to human eyes, automatically rejecting unsuitable fruits before they leave the field. Any tomato that doesn't meet exact specifications gets ejected from the harvester and returned to the soil as compost. Quality control happening across thousands of acres at 5 miles per hour. The journey after harvest would horrify produce managers at grocery stores. Unlike carefully stacked displays, processing tomatoes are unceremoniously dumped into massive trucks without boxes, crates, or protection. They're piled like gravel, often getting crushed in the process. This treatment would ruin supermarket tomatoes, but for processing varieties, appearance became irrelevant the moment they were picked, much like how a race car's paint job matters little compared to its engine performance. Time becomes critical immediately after harvest. These tomatoes must reach processing facilities within hours, creating a logistical operation rivaling automotive just-in-time manufacturing. During peak season, trucks create lines stretching for miles. Any delay risks fermentation in summer heat, potentially ruining tons of product. At factory gates, every load undergoes rigorous testing by quality control technicians. They measure exact sugar content Brix levels, check precise acidity ratios, and scan for contamination. A single failed test can cause an entire truckload rejection, standards as strict as any automotive assembly line. Approved tomatoes enter the factory through water flume systems, industrial water slides that clean and transport them into the facility. This marks the beginning of their transformation from purpose-grown fruits into something completely unrecognizable from their original form. Think those industrial tomatoes are enjoying a gentle water slide as they enter the factory? Think again. Once they plunge into the processing facility, they're subjected to treatment that would make an industrial metal crusher seem tender by comparison. The transformation about to unfold strips away any resemblance to the fruit you recognize. It's manufacturing at its most intense and efficient. Those water flumes serve as the first stage in the tomato's complete dismantling. As fruits rush through these channels, powerful jets blast away field dirt and agricultural residue, simultaneously scrubbing and sanitizing. This high-pressure washing primes the tomatoes for the assembly line of transformation ahead, like a car entering the first stage of production. Next comes the thermal shock treatment, the engine starter of the entire operation. Massive hot water baths and steam chambers blast these fruits with temperatures between 180 to 200 degrees Fahrenheit, comparable to what your car's radiator handles during summer highway driving. This extreme heat loosens the tomato skins and breaks down cell walls, preparing them for complete breakdown. The heat-treated tomatoes feed directly into industrial pulping machines with rotating blades spinning at speeds that would leave your car's tachometer maxed out. These industrial behemoths process up to 400 pounds of tomato per minute, transforming firm fruits into uniform slurry in seconds. The sound rivals standing next to a diesel truck with failed mufflers. Workers wear ear protection as standard equipment, not optional gear. The resulting tomato slurry enters an extraction system separating valuable components from waste. The pulp forces through specialized screens with increasingly fine mesh sizes, functioning exactly like automotive filtration systems. These screens trap seeds, skins, and fibrous material while allowing juice and fine pulp to pass through. The extraction continues through massive centrifuges spinning at thousands of RPM. The same principles used in fuel purification systems. Heavier seeds and skins fly outward for removal, while valuable juice moves toward the center for collection. This extraction efficiency would impress any automotive engineer, pulling every usable ounce from the raw material. By this stage, the tomato exists only in liquid form. Completely deconstructed, this concentrated juice still contains too much water for efficient shipping or storage. Enter the vacuum evaporators, the final tuning phase of this industrial process. These engineering marvels remove up to 80% of water content while preserving flavor compounds, operating under vacuum conditions to lower water's boiling point. The process transforms gallons of tomato juice into thick, intense paste, the foundation for ketchup production. Throughout this transformation, continuous quality testing occurs. Inline sensors monitor bricks levels in real time, while automated sampling systems check pH, viscosity, and color values. Sophisticated analyzers scan for contaminants down to parts per million, ensuring nothing unwanted survives the process. Quality control that matches automotive safety standards. The color analysis proves particularly critical. Specialized optical equipment measures exact red hue against standardized values. Any batch failing to meet precise color requirements faces rejection or reformulation. The same rigorous standards apply to texture analysis, where specialized equipment measures how the paste flows under different conditions, ensuring the final product performs perfectly, just like a well-tuned engine. Behind that perfect red paste lies the real mystery. What exactly goes into creating ketchup's unmistakable flavor profile? The answer involves more chemical engineering than cooking, with precise formulations that transform simple tomato paste into America's favorite condiment. That concentrated tomato paste we followed through production forms the foundation of ketchup, making up about 60 to 70% of its composition. The remaining 30 to 40% contains the carefully calculated ingredients that ensure the ketchup you squeeze onto your backyard burger tastes exactly like the one that accompanied your childhood French fries. Sweeteners serve as the cornerstone of ketchup's consistent flavor profile. While traditional recipes use simple sugar, today's manufacturers primarily use high fructose corn syrup or corn syrup. These provide production consistency, extend shelf life, and deliver that signature sweetness. Each tablespoon contains roughly 4 grams of sugar, equivalent to a teaspoon of sugar in every 4 tablespoons you consume. The tangy kick that makes ketchup instantly recognizable comes from a meticulously engineered acid profile. Vinegar delivers the primary tang, supported by precisely measured amounts of acetic acid, citric acid, and sometimes malic acid. Together, they create a specific pH level between 3.5 and 3.9, essential not just for that mouth-watering tanginess, but for preventing bacterial growth during long-term storage. Salt plays a crucial role beyond just enhancing flavor. A single tablespoon contains approximately 190 milligrams of sodium, more than many potato chips. This significant salt content serves as a preservative that contributes to ketchup's impressive shelf stability. Remember that family road trip where the same ketchup bottle lasted all summer? Thank the salt, though a quarter cup provides nearly a third of your recommended daily sodium intake. The signature flavor we all recognize comes from proprietary spice blends varying by manufacturer, but typically featuring onion powder, garlic powder, allspice, cloves, cinnamon, and celery salt. These spices are dispensed by computerized systems measuring down to fractions of a gram, ensuring the ketchup on your table today tastes identical to last year's version. Texture agents create ketchup's unique flow properties as a non-Newtonian fluid, similar to how toothpaste stays put until you squeeze the tube. Ketchup remains thick in the bottle but flows when pressure is applied. Thickeners like xanthan gum and modified food starch control viscosity with remarkable precision, preventing the separation of solids and liquids that plagues homemade versions. Many commercial ketchups also contain flavor enhancers, carefully formulated compounds that amplify tomato flavor perception without adding actual tomatoes. These target specific taste receptors, creating a more intense flavor than the tomato content content alone would provide. Color additives represent another closely guarded manufacturing secret. While tomato paste provides the base color, natural colorants like paprika extract ensure consistent appearance between batches, contributing that vibrant red that signals ketchup to our brains before we even taste it. Processing aids, enzymes, and clarifying agents that break down cell structures or improve filtration rarely appear prominently on labels despite their critical role in creating ketchup's consistent texture. These behind-the-scenes ingredients help transform simple tomato paste into the perfectly balanced condiment that's accompanied American meals for generations. Those hidden processing aids are just the beginning of ketchup's consistency secrets. Ever wonder why a bottle you buy today tastes exactly like one from 5 years ago? The answer lies in manufacturing precision that would impress aerospace engineers, where massive mixing tanks and computer systems work together to create mathematical consistency in every squirt of America's favorite condiment. When tomato paste enters the final production phase, it flows into industrial mixing vessels larger than most swimming pools. These stainless steel behemoths hold over 10,000 gallons of product, enough for 160,000 standard ketchup bottles from a single batch. This massive scale is essential for maintaining consistency across millions of units while maximizing production efficiency. Inside these tanks, precision replaces traditional cooking. Ingredients aren't measured in cups or teaspoons, but by carefully calibrated weight percentages. Sweeteners, acids, salt, and spice blends enter in specific sequences at precise intervals. This matters because improper combination can trigger negative interactions that compromise both flavor stability and shelf life. The mixing technology creates perfect consistency through high-torque industrial agitators with blades spanning 6 feet across. These create controlled vortices, ensuring uniform distribution without excess air. As the ketchup thickens, the mixers automatically adjust speed to prevent unwanted texture changes. Why does commercial ketchup maintain its texture when homemade versions separate? Asks food technologist Lisa Berger. Homogenization is critical for maintaining uniform mouthfeel. Without it, ketchup would separate more easily and have an inconsistent texture that consumers would immediately notice and reject. Throughout the process, a sophisticated sensor network monitors over 50 different parameters with remarkable precision. Viscosity meters track thickness to within 0.1% accuracy, ensuring that perfect pour every time. Infrared analyzers continuously monitor sugar content, while pH probes maintain acidity at exactly 3.65 plus or minus 0.05. The perfect balance between tangy flavor and food safety. When measurements drift from their targets, automated systems make micro adjustments using precisely metered ingredient additions, similar to how a performance engine computer adjusts fuel-air mixture in real time. This continuous correction ensures every batch meets exact specifications without waste. After mixing comes homogenization, the secret behind ketchup's perfect consistency. The mixture gets forced through specialized valves under extreme pressure, up to 2,000 psi. This intense pressure breaks down all particles to microscopic size, creating a stable emulsion where components remain suspended rather than separating. The molecular restructuring explains why commercial ketchup maintains consistency far longer than any homemade version. The next critical stage, de-aeration, removes tiny air bubbles introduced during mixing. These bubbles might seem harmless, but would accelerate oxidation and spoilage. Vacuum chambers extract these bubbles without disturbing the engineered texture, extending shelf life by months or years while preserving that smooth consistency consumers expect. Before bottling, each batch undergoes rigorous quality testing. Trained experts evaluate samples against 15 distinct attributes, including viscosity, color intensity, sweetness, acidity, and umami notes. Only batches scoring within tight tolerances advance to packaging. Manufacturers also conduct accelerated shelf life testing that simulates months of storage in just days, ensuring your ketchup will taste identical whether used tomorrow or next year. This combination of precision engineering, real-time monitoring, and quality control creates the remarkable consistency that makes commercial ketchup instantly recognizable and impossible to truly replicate at home. Now that our meticulously engineered ketchup has passed its quality tests, it faces perhaps the most visually impressive challenge of all, getting into those familiar bottles at speeds that would make a NASCAR pit crew jealous. The bottling line is where food manufacturing truly mirrors automotive automotive assembly plants, combining blazing speed with microscopic precision. Before a single drop of ketchup enters a bottle, one final quality checkpoint stands guard. The product flows through ultra-fine mesh screens, some as fine as 0.5 millimeters, that trap any remaining particles that might affect texture. These screens function exactly like the final fuel filters in your vehicle's system, catching impurities that could compromise performance. The empty bottles race through what engineers call the rinser-filler-capper block, a synchronized machinery ballet spanning up to 60 feet. Bottles flip upside down as compressed air blasts at 80 to 100 psi, the same pressure as many performance tire setups, clearing manufacturing debris before sterilization occurs through superheated water jets or hydrogen peroxide mist that creates a sterile environment. The sterilization process achieves a 5-log reduction in bacterial load, explains food safety expert Maria Sanchez. That's eliminating 99.999% of potential contaminants without residue. This standard exceeds many medical environments. Think of it as the difference between regular brake fluid and competition grade. The filling station showcases engineering mastery at full throttle. Modern machines use volumetric pistons or magnetic flow meters to dispense ketchup with plus or minus 0.2 gram accuracy, about the weight of a grain of rice. This precision would satisfy even the most demanding German automotive engineers tuning fuel injection systems. The speed dazzles most observers. A single line processes 800 to 1200 bottles per minute. Bottles blur into a continuous stream, each receiving its precise ketchup portion in milliseconds. This production rate matches the RPM of a high-performance engine running at highway speeds. The filling head design is critical, notes packaging engineer Thomas Hansen. We're dealing with a non-Newtonian fluid that changes viscosity under pressure, so the nozzles incorporate anti-drip valves and velocity control. These specialized components, some costing upwards of $1,000 each, handle ketchup's unique flow properties with the same engineering principles that manage transmission fluid under variable pressure. Bottles zoom to capping stations where automated systems apply closures with precisely controlled torque, typically 15 to 20 inch-pounds, similar to the exactness required for cylinder head bolts. This creates a hermetic seal, tight enough to prevent spoilage yet consumer-friendly. The labeling operation matches any robotic automotive painting system for accuracy. High-speed labelers apply decorative wraps and nutritional information at over 60,000 bottles hourly, with optical sensors verifying alignment within 0.5 millimeters, comparable to the precision of modern vehicle panel gaps. Modern systems even adjust label positioning in real time to compensate for minor bottle variations. Throughout this high-speed choreography, inspection systems maintain vigilance. HD cameras capture 100+ images per bottle, analyzing fill levels, cap position, label placement, and date codes. Weight verification systems detect underfilled containers just 1 to 2 grams below spec, the equivalent sensitivity of detecting a missing valve cover gasket. Rejection systems must work flawlessly at these speeds, explains automation specialist Robert Chen. When a defect is detected, pneumatic diverters activate within 50 milliseconds. That's faster than your car's airbag deployment system reacts to an impact. The scale impresses most visitors. A typical ketchup line stretches over 300 feet, with bottles completing this journey in under 5 minutes. At peak capacity, a single line produces up to 72,000 bottles hourly, enough to fill nearly 150 shipping pallets daily. The largest facilities run multiple lines simultaneously, creating millions of bottles weekly, an output that would make any automotive assembly plant proud. And there you have it. From those ordinary looking tomatoes in the field to that familiar red sauce on your plate, ketchup manufacturing is more like an automotive assembly line than anyone realizes. Every squeeze delivers that consistent taste through precision engineering that would impress even the most demanding car manufacturer. What's truly remarkable is how this unseen complexity mirrors the hidden precision in your car's engine, both relying on perfect components and controlled processes to deliver reliability we take for granted. Next time you grab that bottle from your fridge, appreciate the engineering marvel in your hand. What other everyday products in your kitchen or garage hide similar manufacturing secrets? Whether condiment or component, the art of precision manufacturing touches everything in our daily lives.